Okay, it says WZ is equal to 12. That'll be this side over here. If WZ is 12, how big is XY? Also 12. Opposite sides are congruent. If WY, up here at the top, is 14, sorry, that's not WY. The diagonal is WY, my bad. If that diagonal WY is 14, then how big is GY? 7. It is half because that diagonal is being bisected by the other diagonal. Okay. Angle XWZ. XWZ. This angle right here. If that angle is 82 degrees, then what is the measure of angle ZYX? This angle right over here. Also 82 degrees. And then the last one, I'm going to erase all the other markings on this picture so I don't get it too cluttered. If WZY, this big angle right here, is 112 degrees, what is the measure of angle XYZ? This angle right here. How big would that angle be? Close. What'd you say? 68. Yes. Let's look at Y. These two angles here are consecutive angles. They're on the same side of the parallelogram. They're both on the bottom. And consecutive angles are supplementary. So to find the measurement of angle XYZ, we have to take 180 degrees and we subtract 112 degrees. And that gives us 68. So opposite angles are congruent, but same side angles, consecutive angles, are supplementary. They add to 180. Very nice work so far, guys. Let's go ahead and hop into your notes. We have 2 example problems, numbers 4 and 5, that we're going to do today to finish out rectangles. And then with whatever time we have remaining at the end of the period, you have that to work on the homework that's due on Monday, homework number 4. If you did not get that yesterday, it is the very bottom paper in the red paper organizer over here by the board. Before we get into this problem, I want to remind us of the properties of rectangles. So rectangles have all the same properties as parallelograms. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. The diagonals are bisecting each other. But then there's 2 additional properties that we have for parallelograms in addition to the regular parallelogram properties. And those 2 properties are all 4 angles are 90 degrees. And then the 2 diagonals are not just bisecting each other, but they are congruent to each other. Did you have a question? Okay. Wonderful, thank you. All right. So let's see if we can walk through example number 4. It says that quadrilateral JKLM is a rectangle. Then it tells me that MN is equal to 3x plus 1. So this right here is 3x plus 1. JL is 2x plus 9. JL is this other entire diagonal. The measure of angle JNK this angle right here is 5y plus 2 degrees. And the measure of angle JNM is 3y minus 6 degrees. JNM. This angle right here is 3y minus 6 degrees. So using that information, we want to find the values of x and y. We want to find the length of MK. We want to find the measurement of angle JNK and the measurement of angle JNM. So let's find x first. I know the entire diagonal JL is 2x plus 9. And I know that MN is 3x plus 1. How much of a diagonal is MN? Half. It's half of which diagonal? NK. The diagonal JL is congruent to what? MK. So that means JL, the measurement of JL, is equal to the measurement of MK. And MN is half of MK. So 2 segments the size of MN would be the same as MK. So now we can substitute in. We're going to put 3x plus 1 in the place of MN. We're going to double that so that it is the size of the entire diagonal. And we're going to put 2x plus 9 in the place of JL. What's the first thing I need to do now that I've made those substitutions? Distribute the 2. So I would have 2x plus 9 is equal to 6x plus 2. What do I do now? Subtract 2x from both sides. Absolutely correct, guys. Thank you. All right, so I have 9 equals 4x plus 2. What next? Minus 2 from both sides. Good job. All right, 9 minus 2 gives me 7, so 7 equals 4x. Last thing I need to do to find the answer for x. Divide both sides by 4. I can either leave this in its fraction form or in its decimal form. What is 7 divided by 4 in its decimal form? 1.75. So 7 over 4, or 1.75, is the value of x. Well, before we go on and find y, is there anything that I'm going to be able to find using that answer for x? Anything else that they want me to find that I can use my answer for x to find? MK. How do I find MK? What would I need to do to find MK? I love it. JL is the same size as MK. MK equals JL. So we can substitute in the expression for JL, 2x plus 9. And then we just found x. We found out that x is how big? 1.75. So 2 times 1.75 plus 9. What is 2 times 1.75? 3.5 plus 9, 12.5. So MK is 12.5. Right, now we need to find Y. Y is part of angles. Y is part of this angle right here and this angle over here. What do we know about those two angles? They're a linear pair. Absolutely correct. So angle JNK and angle JNM are a linear pair. Why do we care that they're a linear pair? Because if you add them together, they equal 180. Absolutely correct. So the measurement of angle JNK plus the measurement of angle JNM is equal to 180 degrees. So now we're going to substitute in these expressions. What should I put in for the measurement of JNK? How big is angle JNK? 5y plus 2. And then what are we putting in for JNM? 3y minus 6. And that's equal to 180 degrees. So we're going to combine our like terms together. 5y and 3y would combine to give me what? 8y. What about 2 minus 6? Negative 4. So 8y minus 4 equals 180. What do I want to do now? Add 4 to both sides. So I have 8y equals 184. And now I do what? By 8. Divide both sides by 8. And that means y is how big? 23. Now we need to go in and find the measurement of angle JNK and JNM. The measurement of angle JNK, what was the expression that we had for that one? 5y plus 2, and we just figured out that y is how big? Y is 23. So I have 5 times 23 plus 2. What is 5 times 23? 115 plus 2? 117. So the measurement of angle JNK is 117 degrees. And then we have angle JNM. What was the expression that we had for JNM? 3y minus 6. We just found earlier that y is 23. What is 3 times 23? 69 minus 6? 63. So 63 degrees. Can anybody see another way that I could have found that answer without substituting in? Yes. We could have taken JNK, 117 degrees. We could have minused that from 180. Because remember, JNK and JNM add up to 180 degrees. So we could find one and then minus from 180 to find the other. Very nice work. All right. One more problem. Last one. We have that quadrilateral PQRS is a rectangle. I said that the measure of angle PTS is 40 degrees. PTS is 40 degrees. PQ is 12. And PS is 5. They want me to find the measurement of angle PTQ. PTQ, this angle right here. How would I find that angle? Subtract 40 from 180. 180 degrees minus 40 degrees would give me what? 140 degrees. So my first answer is 140 degrees. I'm going to go add that to my picture. Because 140 plus 40 equals 180. All right, next up, we want the measurement of angle PQT. PQT, this angle right here. Well, if I'm looking up here, it makes a little triangle. And we already practiced with parallelograms because I know the three angles in a triangle have to add up to how much? 180. The three angles in a triangle always add up to 180 degrees. But do I know two angles in this triangle? No. Here's where we have to use one of the special properties for rectangles that does not apply to parallelograms, only to rectangles. Does anybody remember what we've said about the diagonals? The diagonals are congruent, and what are they doing to each other? Bisecting each other. If I have two sticks that are the same size, and I break them both exactly in half, what would be true about those four little pieces that I would have done? They would all be congruent to each other. So PT is the same size as TQ, is the same size as ST, is the same size as TR. So now when I'm looking at this triangle up here at the top, I know that this is what type of triangle? It's an isosceles triangle. Triangle PQT is an isosceles triangle. An isosceles triangle has two congruent sides, and it also has what? Two congruent angles. These two angles right here are congruent to each other. I don't know how big either one of them is. So what could I call that angle if I don't know how big it is? X. And if the angle that I'm looking for gets called X, what should I call this angle over here? I could call that one X also. Because why? Because it's the same size as the one on the other side. So both of those would be X. They're both unknown, but they are the same size, which is why I can use the same variable to name them. So now I can take X plus 140 degrees, and that is equal to 180 degrees. So what would I want to do now? Yep, I got my equation wrote. X plus 140 equals 180. Add like terms, so we're going to combine the X and the X together to get what? 2X. So 2X plus 140 equals 180. What now? Subtract both sides by 140. So 2X equals what? You're just one step ahead. 2x is 40, so x would be how big? 20. So x equals 20. And x is representing what here? Which angle? Which one were we looking for again? PQT. So the measurement of angle PQT would be 20 degrees. The only reason I was able to do that is because this was an isosceles triangle. If I did not know that that was an isosceles triangle, I would not have been able to find the size of these angles. They had to be the same for me to solve this problem. All right, next one they want me to find is TRQ. TRQ, this one right down here. Do I know the size of any of the angles in that triangle? Which one do I know? 40. These two angles right here are vertical angles, so they would be congruent. So this angle over here would be 40. So now I do know one angle there. What else do I know about, about this triangle right here? It's also isosceles. It has two congruent sides. So triangle QTR is isosceles. We already used X. Are you guys okay using Y now? All right, so let's use Y for the angle that we're looking for. Angle TRQ. What other angle would be the same size? TQR. These two base angles, only because it's isosceles. So now we can do Y plus 40 is equal to 180. All right, where to from here? Add our like terms together, so we're going to combine y and y together. So 2y plus 40 equals 180. What next? Yep, minus 40 from both sides. So I get 2y equals what? 2y equals 140. So how big is y? Y is 70. We divide both sides by 2, and we get that y is 70. And what were we using y to represent? TRQ. Measurement of angle TRQ is equal to 70 degrees. So let's go add that to the picture. $70 degrees, 70 degrees. I do see another way that we could have come up with this answer. What do we know about all four angles in a rectangle? They're all 90 degrees. So this angle up here is how big? Right here. That's a 90-degree angle. And we found, when we found PTQ, that this angle right here was 20. I know it has to add to 90. So 90 minus 20 gives me the size of this angle right here. All right, two more things that we need to find. PR, where's PR? Let me see if I can trace over it with my highlighter. PR is this right here. That is one of my diagonals. How big is SR? 12. SR is 12 because it is congruent to PQ up at the top here. And now I want to look at this triangle right here. So just the lower left triangle inside this rectangle. What kind of a triangle is that? It's a right triangle. And we are looking for which part of that right triangle? The hypotenuse. We want the side that is opposite that right angle. How can I find the hypotenuse if I know two sides? Pythagorean theorem. A squared plus b squared equals c squared. Where do I put the 5 and the 12? In for a and b. So I have 5 for one of them and 12 for the other. Parentheses and square plus parentheses and square equals c is always the hypotenuse. So if I'm looking for a diagonal, I'm looking for c. What is 5 squared? 25. 12 squared? 144. What is 25 plus 144? 169 equals c squared. Now what do we do? Square root it. If you do it to one side, you got to do it to the other. The squared and square root cancel out on the right. What is the square root of 169? 13. This is one of my Pythagorean triples. This is a 5, 12, 13. And what was c representing for us? PR, the hypotenuse. So 13 is equal to PR. All right, last thing I need to find is TQ. TQ is this piece right here. Oh, I'm not doing a very good job of making that show up. Let's see what I can do. TQ is this right here. What do we know about that? It's half of SQ. All right, so let's write that down. TQ is half of SQ. Well, how big is SQ? It is 13. Why do we know it's 13? There we go. SQ is congruent to PR because the diagonals are congruent to each other. So SQ is equal to PR, which means I can make a substitution here. Instead of SQ in the parentheses, I can replace it with something of equal value, PR. And how big is PR? So half of 13 would be what? 6.5. Very nice work. So because those diagonals are congruent, we can find half a diagonal for the other one, because all 4 of those half diagonals are congruent to each other. Because we have 4 right angles, if I know 2 adjacent sides, I can use the Pythagorean theorem to find the diagonal. The other thing that we can do, because these 4 half diagonals are the same size, is that we can use the triangle sum theorem for isosceles triangles to find these 2 missing angles, or these 2 missing angles here. And if you can find shortcuts, like you know this is supposed to be 90 degrees, if you find one piece of it, you can use subtraction to find the other part. That covers everything that we needed to go over today. Homework number 4, which again is the one you guys grabbed on your way in the door yesterday, is due on Monday. I am happy to answer any questions for you on that homework whatsoever. Also, just one thing quickly, if you look at the back side of that homework, up in the top right corner, there's a little rectangle with the diagonals drawn in. You will use that rectangle to answer questions 10 through 14. So that little rectangle is for all 5 of those questions. When you get to 26, that's an entirely different question that doesn't relate to the picture. but 10 through 14 all go with that rectangle.